So today we are learning the subject of network analysis or circuit theory. So very good morning one and all. So our chapter was the steady state and the transient response. Today we will see here in the steady state response or the analysis, steady state analysis as well as the transient response is the chapter. In that there is a two section is there. One is known as the steady state response and other is nothing but the transient response. So today we will continue the steady state. Already we have discussed on the topic of theoretical content related to the steady state as well as the transients. Okay, so today we will go for the steady state, and that too we will see the few responses or the numericals related to the series as well as the parallel circuit. Okay, if you're talking about the series and the parallel, definitely RLC circuit will be there. So today in this session we will continue only the series responses, that to RLC circuit. All of you keep ready the pen, notebook and your calculator so that you can simplify the numerical yourself and you can cross verify the answer with the help of the calc. Try to understand the numerical one by one, which is related to the steady state response. We focus on steady state. Okay, steady state response and that to RLC circuit. So what is that numerical? I'm going to read, all of you pay attention on that numerical. So the numerical is a 50 Hertz sinusoidal voltage, a 50 Hertz sinusoidal voltage, a 50 Hertz sinusoidal voltage I request to a 50 Hertz sinusoidal voltage. V is equals to 311 sin omega t. V is equals to 311 sin omega t is applied to a is applied to a is applied to a RLC series circuit is applied to a RLC series circuit, only RL, so on RL series circuit, if the magnitude of resistance is 5 ohm, if the magnitude of a resistance is 5 ohm and that the inductance is 0.2 Henry, inductance is 0.2 Henry, comma, A part. Calculate the RMS or effective value of steady state current and relative phase angle. Relative phase angle. Number 2, obtain the expression for the instantaneous current. Obtain the expression for instantaneous current. Third, compute the effective magnitude and the phase of a voltage drop appearing across each circuit element. So if you observe this numerical, if you are trying to understand this numerical, first of all, the circuit is related to RL. The circuit is related to the series connection. It means that only two components are there which are connected in series. That is, resistor as well as inductors are connected in series. First thing. Secondly, the frequency and the voltage is given. That is a sinusoidal source voltage is there. That is V is equals to 311 sin omega t is given at the input side, and the frequency of that is nothing but the 50 Hertz. Apart from that, two components magnitudes are given. that is nothing but the resistor value is 5 ohm, whereas inductance value is 0.02 Henry. So what we need to calculate here? We need to calculate the effective voltage, okay, the effective value of your the steady state current, that is nothing but your the I we want to calculate along with your the phase angle. Second is nothing but the equation related to the current. Third is nothing but the what you can say the magnitude and the phase of your the voltages. Okay, so these three things we need to calculate. How we can start? The first is you have to note down, that is nothing but a part. So V is represents the RMS value, because why we are talking about all these things VRMS and all, just because of the steady state responses. Okay, so what you need to do here, you need to elaborate your what we can say the numerical. So how we can do it? So by writing the expression, that is a part, let capital V represents the RMS value, and that can be taken as V is equals to, we are doing the sinusoidal or you can say the AC, or you can say the simply what we can say the series circuit, series network, and that too sinusoidal. Okay, AC analysis is important here. That's why V representing the RMS. If we are talking about the VRMS, definitely the formula related to that, V is equals to Vm by root 2. Already you have might be studied in the other subject, just like you are the EDC. So V is equals to Vm by root 2. So what is my Vm? There is a standard equation of your Vm is given already. That is nothing but 311 sine of omega t. Okay, so that is V is equals to Vm sine omega t. Okay, in short, V is equals to Vm sine of omega t. So what is here? The magnitude of that Vm is nothing but the 311, and root 2 will be the as it is. In this way you will get as 220 volt is nothing but your the VRMS value. Exact VRMS value is nothing but 220 volt. Similar to that, in further cases, we are interested in the phase angle. Whenever we are talking about the phase angle, definitely I should think about for the keeping in your mind, that is a AC analysis circuit, and that we should reflect the equation in the form of a real as well as the imaginary part, and know very well how we can write that equation. So you can start with, if nothing is given, you can assume your angle is 0. So here I am writing this expression in the form of your the rectangular, and in the rectangular we know very well real time plus of j of imaginary. Okay, real magnitude plus j of imaginary magnitude. So here 220 is the magnitude of the V plus j, nothing, that imaginary part is nothing but you need to take the 0. Now here just do with the help of the CASI the conversion in your the CASI. Already we have studied the steps how to convert the rectangular to polar. Take this magnitude, then the shift is there button, then the rectangular to polar option is there, then put then 0, then again equals to, and the shift somewhat. These are the steps to convert the rectangular to polar and the polar to rectangular. So likewise just do it. 220 plus j of 0 rectangular form into the polar, you will get the magnitude will be the same one, that is nothing but the 220, and the angle will be the 0 degree volt. So in this way we have converted this r plus j of what we can say r plus jx, you can say, if nothing is there means 0. So in this expression, that is in the form of the rectangular converted into the polar form. Now why we are going to calculate the current? We know very well the basic formula related to current is while you are considering the AC analysis, that is I is equals to V by Z. Instead of taking the R we if we are having only one component, okay, but we are talking about the AC analysis, definitely my Z will be there, because Z is equals to R plus J of X, and we are taking that X is nothing but maybe the XL and maybe the XC, totally depend upon the circuit which is mentioned there, whether you are having the inductor, whether you are having the capacitor. If you are having anyone, you need to consider that X will be equals to, if inductor is there, XL, if capacitor is there, X is equals treated as a XC. If both are there, the XL and the XC difference of that you need to consider, which is greater one, which is lesser one. Depending upon that you can do it. So already we have simplified many numerical on that. So I is equals to V by Z will be the case. Now come to the point, which is the unknown parameter. Here in this case, that is nothing but the Z. How I can calculate my Z? Z is equals to R plus J on X. At the beginning, one just increase one step, that is R plus J of X will be the here case, and later on again equals to R plus J of omega L. Okay, that x will be treated as your the omega L. X will be equals to omega L for the inductor, and x is equals to 1 by omega C for the capacitor. In short, you can say XL and XC. That x will be converted into the XL, and that XL will be converted into the omega L. The x will be converted into XC, and XC will be converted into 1 by omega C. It's totally depend upon the component which is given here. So now come to the point that XL is equals to omega L, and omega is nothing but the 2 pi F. L will be the as it is. So R is the 5, J will be as it is, and the omega is nothing but 2 pi 50, L is a 0.02. So in this way, you will get as after multiplying this 2 pi 50 and the 0.02, you will get 5 plus J of 6.28 ohm. In this way, you can convert root of first term square and the second term square. If you don't want to do with the calci, that is the other possibility, that is these two term you can take in the root, that is first term square and the second term square, angle of tan inverse of second divided by the first one, that is nothing but you are the XL divided by R. This is also one of the possibility without doing the calculator or converting that polar to rectangular or rectangular polar. You can convert into the, see here the rectangular case into the polar. See here, root of first term square, that is r square plus x square, that is nothing but the xl, angle of tan inverse of your the xl divided by r. Now the answer will be 8.03 and angle of 51.47 degree ohm. So in this way you can do with the calc. I hope you are getting this answer if you're trying yourself. So now come to the point, what is my equation of the V? V will is nothing but 220 angle of 0 degree. Now the Z is nothing but 8.03 angle of 51.47. Now these two magnitudes and these two are angle, and already we have studied the magnitude will be cancel out, that is nothing but 220 divided by 8.03, that is Z1 divided by Z2, or anything you can consider here. The situation, that is a 220 divided by 8.03, angle of theta 1 minus theta 2 is nothing but 0 minus of 51.47. So in this way you will get 27.39 after this division, and 0 minus means minus of 51.47 angle. So in this way you got this the value of the current in the phase angle. Next, that is nothing but your the how we can get the other parameter. So B part, note down here the B part. The instantaneous current is that given by second B part, you need to calculate the instantaneous current. How we can calculate the instantaneous current? Small I is equals to Im sine of omega t plus theta. Small I is equals to Im sine omega t plus theta, bracket close. What is my Im, which I have calculated in previous case, A part, 27.39 into what is my what we can say the rest of the part. In short, you can say whatever you are calculating effective into the root 2 is nothing but the Im. In the previous case you have calculated the effective current, so that effective current into the root 2 is nothing but my Im sine of omega t minus of that theta is nothing but 51.47. Now substitute the value. Already you know very well that is nothing but, if you don't want to substitute omega t value, keep it as it is. So here will be 38.73. If you are going to multiply 27.39 and root 2, so you will get as a 38.73, and the sine will be as it is, omega t will be as it is, and 51.47. Otherwise you can substitute the value of omega is here also 2 pi f. So but no need, again the question arises for the teeth and you need to take the t as it is. So better way you just complete omega t, keep it as it is. So in this way whatever you are getting, that equation is nothing but the instantaneous equation or the instantaneous current expression, and that is current is measured in the ampere. So I is equals to 38.73 sine omega t minus 51.47 degree for 47 degree ampere. Now third case, the voltage drop across the resistor is given as. So what they are asking, the voltage drop across the inductor, the voltage drop across the what we can say the resistor, and the combination of these, that is nothing but the total voltage. You can get it. So voltage drop across the resistor VR. VR is nothing but voltage drop across the particular resistor. Okay. So voltage drop across the particular resistor is nothing but your the VR is equals to IR. You know very well with the formula. What is my IR? That is the I effective 27.39 angle of minus 51.47. IR is nothing but the 5. Multiply these two magnitude, that is 27.39 into the 5. You will get as 136.95 and angle of minus 51.47 degree volt. Now next is nothing but voltage drop across the inductor, that you can calculate as VL is equals to JIXL. VL is equals to this. Here we are taking as a imaginary, while you are going to solve the what can say the AC analysis, and that the voltage drop across in the sinusoidal waveform. The we remember VL will be always J of I XL. So J of I is nothing but again the effective, that is 27.39 angle of 51.47 degrees. So in this way bracket close. And what is my XL? XL is equals to omega L. So what is my omega? 2 pi FL. Okay, so 2 pi FL already we have calculated 6.28. So this magnitude will be multiplied with each other. Okay, you will get 172. Angle will be added theta 1 plus theta 2. So theta 1 is a 90 degree. Okay, if nothing is there means this here it will be 90 minus of this 51. 90 minus of this 15, you will get 38.46. So if you are going to add the total voltage is equals to voltage drop across the resistor and the inductor, so you will get the 220 plus J of 0 volt. How? By adding these two values, that is 136 angle of 51 and second is nothing but the 172 38 point. Likewise, if you are going to, this is nothing but for our simplicity to cross verify whether I am getting the same voltage or not. Otherwise, it is sufficient. The voltage drop across the resistor and the inductor is nothing but your the total voltage across that circuit. Now come towards the next numerical number 2, which is on the steady state, what you can say sinusoidal RLC series response. So what is that? Note down all of you. In a series RL circuit, R is equals to 10 ohm, L is equals to 20 millihenry. The circuit current begins at 10 sine 314 t ampere. Find the total voltage drop V across the element of R and L. Also obtain the phase angle between the I and the V. See here, in this case, two parameters. What they are talking about, the two things, that is nothing but phase angle we need to calculate and obtain the phase angle between the I and the V. Okay, obtain the phase angle between I and the V means the theta while you are going to calculate the current, and the theta while you are going to calculate the voltages in short. So how I can calculate my theta? Theta is equals to tan inverse of omega L by R. Already these expressions are derived expressions, so directly you may consider that is theta is the phase angle theta between the V and the I is given by this statement should be there before going to start this issue solution. So here note down the phase angle of theta between the V and the I is given by theta is equals to tan inverse of omega L by R. So what is my omega? Omega is nothing but again the 2 pi FL. So 2 pi F is the 50 hertz, L is given there the 20 millihenry. So 20 into 10 raised to the power minus 3. R is given as the magnitude 10. So if you also just multiply this section and this section and dividing later on, so you will get as a 32.13 degree. So in this way, what is my equation of I, which is given in above? I is equals to 10 sine 314t. Already they given the expression in the numerical, that is I is equals to 10 sine 314t. If you compare this expression with the standard I is equals to Im sine of 314t, so you will find the omega will be the 314. Omega is nothing but 314, which is equals to 2 pi F. Okay, and F we know very well, that is a 50. So in short, you can say if you are multiplying 314, you will get. So how you can calculate your the voltage? Voltage is equals to Im root of first term square is nothing but the R square plus this inductor is there the omega square. Getting the first term square into the second term square, that is first term is the R square, second term is nothing but the inductor, that is nothing but the omega L square. Sine will be as it is omega t plus of theta. In the previous case we have done for the voltages, so here the for the current we are doing, we remember in the previous case, so the there was a root of r square plus same x square, and here was the sine omega t plus theta. So what is my Im, which is given in the expression, that is nothing but the 10. Okay, magnitude is Im is nothing but the 10, and root of first term is nothing but the r square, that is 10 square, omega is nothing but 314, into what is my L, 20 to 10 raised to the power minus 3 of bracket of whole square. Sine will be outside the root, so sine 3 1 4 t plus theta. So in this way, if you multiply this case, if you add this case and the root and then multiply with the 10th, you will find 118.08 sine of 3 1 4 t plus 32.13, which already we have calculated this angle 32.13 in first step, right? You can write here the theta value. So in this case, we have find the angle between the current and the voltages, that is I and the V. So we have calculated. Now the go for the third numerical again, which is related to the series circuitry of your the RLC, steady state response. In a series RL circuit, the current and the voltages are given as I is equals to 1 cos in bracket 3 140 minus 20 degree bracket close, V is equals to 10 cos 3 140 plus of 10 degree. We can say T plus 10 degree. So find the value of your the RLN. Here the inverse, what we can say vice versa, the situation is there in this numerical. Previously we have simplified the, what we can say, the resistor value was given, the inductor value was given. We were interested in the other parameter, just like your the current, effective current, we were interested in the angle and all. But here the two expressions are given, that is a current equation as well as the voltage equation. Now we need to find out the unknown parameter of your the resistor as well as the current, which are connected in the series, and that to analysis is your the AC. Why I am focusing every time that is AC analysis? Because if you are treating the DC, there will be no angle, there will be no impedances and all. That's why in AC analysis everything will be there. Ready? So now how we can start? Like the V will be the reference vectors. I lacks the V by the 20 plus 10 is equals to 30 degree. Why this is the situation? See here, V is the reference vector, no doubt at all, and the I lags. So we remembered, if you're talking about the inductor, the current is always lags with the voltage, whereas in the capacitor current is lead with the voltage. So just because of this expression, as we know very well, this is the R and the L, so that's why the current is lagging with the voltage. Okay, lagging with voltage means what you need to do, these two will be what we can say, 20 plus 10. If you are adding this plus or minus is there, 314 omega t plus or minus theta. Omega t plus or minus theta is totally depend upon the lead and the lag, but the voltages we are talking the vectors of voltages, so angle will be added. So 20 plus 10, that is nothing but the 30 degree. How we can find the ratio? That is Vm by Im. Vm is given as what is given the Vm, that is nothing but the 10 here. What is the Im? That is nothing but the 1 here. So 10 divided by 1 is nothing but my again the 10. So 10 by 1, how I can calculate the root of r square plus, already we have done in the previous numerical also, that is omega L square. What is my omega? Already given in the expression in the both the side, that is a 314 is my omega into L whole square. The L is unknown, R is also unknown. So the squaring on the both the sides. See here, 10 by 1 is nothing but the 10, and the root of R square plus 314 into L whole square. So this 314 will be the squaring term, but L square will be as it is and R square will be as it is. So just note down here the one sentence, that is nothing but squaring on both the side. Squaring on both the side. After this root, just mention squaring on both the side. What will be the case then? R square plus 314 dot of L of whole square is equals to this 10 will become as 100. Now come towards the point how you can find the angle of a 30 degree. You can find that is nothing but you are the 0.577. Okay, what is this situation? This is nothing but you are the again 314 L divided by R. If you are going to simplify this equation number 1, and the equation number 2 is by the for the angle, you can treat it for the angle, that is nothing but tan 30 degree. Just find out which is equals to omega L by R. Omega L by R. So by solving the equation number 1 and 2, what is the equation number 1? That is the R square plus this one. And what is the equation number 2? That is the this one. So this we are doing separate out, otherwise it is in the combined in the previous numerical, that is angle we have calculated, but here the unknown parameters are R and the L. That's why we have separate out. By separating these two equations, we can find easily by comparing this equation of your the equation number 1 and the 2. If you are going to compare, and definitely any one parameter Whenever you will get from this situation, you can substitute in the above equation so that you can simplify easily. So you will get as after equating and the solving the equation 1 and 2, L is equals to 15.9 millihenry, whereas R is equals to 8.66 ohm. 8.66 ohm. Again, in this way, we can simplify uh, the numerical on the steady state response of your the series RLC circuits. That is a fourth one. What is that? Numerical number 4. In a series RC circuit, the value of your the R is equals to 10 ohm and the capacitor is 25 nanofarad. A sinusoidal voltage of a 50 megahertz is applied and the maximum voltage across the capacitance is the 2.5 volt. Find the maximum voltage across the series combination. So in this case, if you observe, the first change is nothing but the connection is series, no doubt at all, but the circuitry is your the resistor as well as the capacitor. Resistor as well as your the capacitor. So resistor is connected in series with your the capacitor, and the sinusoidal voltage of the 50 megahertz, sinusoidal voltage of a 50 megahertz mm, megahertz is applied, and the maximum voltage across the capacitor is 2.5 volt. Find the maximum voltage across the series combination. What is the question here? We need to find out the maximum voltage across the series combination. So how we can start this? No doubt R is R and the C are connected in series. AC sinusoidal, the source voltage is there. Okay, so see here what is given with the help of parameters. R is given, C is given, and the capacitance voltage drop across the capacitance is 2.5 volt. Fine. So solution will be the omega is equals to 2 pi f. We know very well the f is nothing but the 50 mega is given. That's why 10 raised to the power 6. If you convert this angular frequency, the radian per second will be uh, the angular frequency, the current through the capacitance being given by. So this is the expressions already derived expression. That is for this situation you need to take the current I is equals to omega cv. Okay, I is equals to omega cv. Omega is angular frequency which is given above. Capacitor is value is also there, and the voltage drop across is also there. So here what we need to do, I max is equals to what they are asking for the maximum current. I max is equals to 2 cv max. 2 C V max. I max is equals to omega C V max. What is my omega? 314 already have calculated into 10 raised to power 6 radian per second already we have done. What is my capacitor value? That is nothing but here the 25 nanofarad. 25 nanofarad. Nano 10 raised to the power minus 9. And what is the given the maximum voltage across that capacitor is 2.5 volt. So if you multiply all these things, you will get as 19.62 ampere. That is the maximum current across that capacitor if you're having the voltage, maximum voltage drop across that particular capacitor, so that you can find the how much amount of a current which is flowing through the RC circuits. Now again, V is equals to IZ. Already the basic formula related to the V is nothing but V is equals to IZ. V max is equals to I max into the Z. Okay, that again you can calculate as I max will be the as it is. How I can get my Z? Z is equals to the alternate formula for the Z is equals to root of R square plus 1 by omega C square. Root of R square plus 1 by omega C square. Already these things we have done in the previous chapters. Okay, how I can find out the R related to the L, how I can find out the Z related to the L, how I can find out my Z related to the C. So Z is equals to uh, R square plus 1 by omega C in the root we can find. So what is my I max? That is a 19.62 root of what is my R? 10 square plus a 1 by omega C. Already we have done this. To omega is nothing but the 2 pi f, and the C value is already given here. They just squaring that one, and again the 10 square, add these two, do the root term and the multiply with 19.625, you will get as 196.59 volt. 196.59 volt. So now last numerical related to the steady state series RLC response is, in a series RLC circuit, the maximum inductance voltage is twice the capacitor voltage maximum. However, the circuit current is lags the applied voltage by the 30-degree, and instantaneous drop across the inductance is given by the VL is equals to 100 sine 3770 volt. Assuming the resistance being 20 ohm, find the value of the inductance and the capacitance. So see here the solution. Here if you observe, we have seen the numerical on the RL, we have seen the numerical on the RC. Now the time comes here, the RL and C, these three components are connected in series in the sinusoidal steady state response. So see here the inductor drop is given in the above, that is nothing but your the VL is given 100 sine 3770. So in voltage drop across the inductor is 100 volt, which is the maximum. So VL max is nothing but the 100 volt. How I can write the VL in terms of the inductor? So VL is equals to omega L I max. VL max is equals to omega L I max is the formula. VL is equals to omega L I max. What is my VL max? Which is given 100 volt. Okay. So in this way the 100 volt you can take. Again one more statement is given. Inductor drop is twice the capacitance drop. Twice the capacitance drops. That also you need to consider. Okay. So if you are talking about that what we can say that twice, here this 2 will be multiplied with a 2xc. That's why we have taken here the half of that inductor. So 1 by 200 into I max xc. So what is my I max? What is my xc? X is equals to 1 by omega c. We remember always xl is equals to omega l, whereas x is equals to 1 by omega c. So at the place of xc, here 1 by omega c, and I max will be the as it is. So here will be the 50 omega. 50 omega is equals to I max. Omega will go up and C will be as it is. So here will be the situation of your the 50 omega I max into C. Then again the what we can say 100 omega into I max into L will be as it is inductor value. We can simplify that. How I can find my angle? Tan theta is equals to omega L minus 1 by omega C. This angle, see here the difference in the theta, tan theta in every cases in terms of the RL, in terms of the RC, and in terms of the RL and C. Here is a change in the formula for the tan theta just because of the RL and C. All the components are present here. So tan theta is equals to omega L minus 1 by omega C. That is nothing but you can say XL minus 1 by omega C. Sorry, XL minus 1 by XC. You can take, or you can say the omega L1 minus 1 by omega C divided by R. You can substitute the value. Tan theta, theta is nothing but the 30 degrees given. Omega L minus 1 by omega C. Again, the magnitude of R is given here. So, now here there will be the multiplication. Omega will be square. LC will be as it is minus 1 by this 20 into omega C will be come into the denominator. So in this way you can simplify the solving the equation number 1 and 2, which is in the previous slide. So you will be able to find omega square LC is equals to 2. Okay. And by substituting the value of omega square LC in the equation number 3, you will be able to find as a 0.577. You will get here at the place of omega, square LC. You can get, after simplifying, solving the equation number 1 and 2, you will be able to find omega square LC is equals to 2. Just substitute this value in the equation number 3. So you will get as a 0.577 is equals to 1 by 20 omega C. And the last is nothing but how you can calculate the capacitor is 1 by 20. That is nothing but again the to 0.577 omega, and you can substitute the value of the omega. So you will get the capacitor value 230 microfarad. Now thus from the equation number 4 we can get, in short, you can get from the equation 1 and 2, you are getting the omega square LC value. From the equation number 3, you are getting the capacitor value. And the last, from the equation number 4, you are getting the inductor value. So in the inductor value, L is equals to 2 by omega square C. Okay. So 2 by omega square in the previous, you can find in the, what we can say, how is here, the is here. In this case, L is equals to 2 by omega square by C. Likewise, you can get the, what you can say, L is equals to 2 by omega square C. So 2 divided by omega square 377 square, and capacitor is nothing but 230 volt raised to the power minus 6 you can get, and in this way you can get the inductor value 61.18 millihenry. 61.18 millihenry. Okay, so in this way we have solved the numerical which was related on the chapter of your steady state responses, and we have simplified 5 numerical in this session related to the sinusoidal series RLC circuit of a steady state responses. Steady state responses of a RLC series circuit sinusoidal. So in this way we have simplified the numerical on the steady state responses. Thank you so much.